Couple of slides with you right now so you can do the assignment that I have posted for you on Wednesday on perceptual constancies. This is going to be really fun. It's going to be really easy and really quick, but I kind of wanted to go through a couple of ideas so maybe it can generate some things about what you could do to show us a perpetual constancy. So in order to perceive whatever it is that we are sensing, right? And for our purposes, it's really going to be what we see. We have to maintain that understanding of a constant, meaning even if it looks like it's changing or moving or a different color or something, variations in light, it still stays the same. Now we know this, however, what our eyes are perceiving is different what our brain is interpreting. And so this is called constancy. So for instance, this is a good idea of color constancy. We can perceive objects as being a constant color. I have this little graphic and I actually have to print it out and prove to students that blocks A and B are the same block. In fact, I have it right here and I print it out and I have to move my paper, and so students can see if you look and you just isolate A and you isolate B, those are the same color. A and B are the same color. That's a little bit hard to perceive. If you choose to do color constancy, I think one of the easiest things to understand color constancy is, maybe put your phone up or your iPad up to a pair of sunglasses and take a picture of it, of whatever it is you want it, like the grass or whatever it is, and then take a picture of without sunglasses on, because when you look at, say, something with sunglasses, it's a different color, it's a different shade, but you still know the grass is green, right? This is color constancy. Oh, is this not cool or what? These blow my mind. I'm looking at this guy and right away I'm seeing he's straight on. He's looking at me with half of his face. I see the right side of his face. Oh, now now I went back and now I see it's the side profile, which would essentially be his left eye. I don't even know. This is it. Just I go back and forth and back and forth. This is the idea that there's a constancy. And it's not, his face hasn't changed. What is it in your brain that's interpreting the way you see this? I think that's just kind of fun. Oh, this is a fun one too. Can you imagine the angle that must have been taken at up ahead? If you can look there, those are a bunch of sailboats on the water, and then there's some sort of gathering there off, maybe away from the beach area in a grassy area, and then the picture probably was taken from a high vantage point. So let's talk about then. Oh, this is kind of fun too. Can you read that? This is all baloney. It's not from Cambridge University, but it is showing you that your brain can perceive things even if they are the wrong words. Shape constancy. Shape constancy is when we can see different angles produce a different shape on the retina, but we know that is still the same. So for instance, that picture, again, students hate it. I'm like, well, that's the same table. It's just taken from a different angle. Students are like, no, that is not the same table, but it really is. In fact, actually, that's showing you shape and, I just noticed, shape and color constancy, because you can see the color underneath looks like it's grayed, but we actually know it would just completely be white, but because of the shadow, it's going to be kind of grayish, if you will. But shape constancy, this is an easy one to do too. Now, you can't use this example, but take a quarter and take a picture of a quarter straight on, and then take a picture of a quarter that's at, the side angle or the side of a quarter. You still know it's still a quarter and it doesn't change its shape, even though it looks like it's very different. It's how that image is falling on the retina. But your brain interprets it as the same size, even though the image on your retina is being transcribed as something different. your perceptual constancy says it doesn't change. This is a good one where if you kind of like look down in the horizon, like down, like say long railroad tracks or down a long hallway or something, and you see two people, is one like look giant compared to the other one? That would probably be more, oh, this is a good one too. If you're in class, we're gonna do this. Literally, people have to cut these out. I have like these little shapes of these like train tracks. They got to cut them out because they just cannot believe that those are the same size. This is called the Jastrow illusion. So here's the other one that I was talking about, size constancy. And the idea here is that objects don't grow or shrink as they move closer or further. The best example of this is actually from our author, Philip Zimbardo. Is in this video that I embedded, he does this illusion of a rectangular room. So again, remember when we were talking about perception, bottom up and top down, you have to have some sort of context in which to make this relational and understandable and perceivable. So if we had time, which we don't, and if we were all together, I'd actually have you cut out a little Ames room, and you can see this illusion of a rectangular room. So watch that YouTube video. It's just real quick. If any of you have ever been out to, I think it's in Rapid City, I've never been there myself. Out in Rapid City, they have a kind of like a recreation park. It's not like a museum, but it's like a mystery house or something. I think they also have one in Medora as well, where you can go and you understand, like, you're going to be standing by somebody and you're going to look like a giant, and they're, you know, like a fun house, and they're going to look tiny even though you are the same size. Maybe size constancy, a good picture that you might be able to take would be like showing me two doors or something, and the one door is open and the other door is closed, and that object doesn't grow or shrink if you like are closer to the door or you're further away from the door. So these are lots of examples. I don't want you to use any of the examples that I have given, but you can literally practically do anything. And as long as you explain it as either the color constancy, the shape constancy, or the size constancy, and we can tell that on two different pictures. So what I want you to do are take two different pictures of a similar image of the same, or maybe just different angled image or whatever it might be. It can be something in the shadows. It can be something that is one angle this way and another angle this way. It can be something that's further away here and closer here. Whatever it happens to be, upload me two images on Padlet, and what I put in the directions is first come, first serve. I want you to take a look at Padlet before you do it, and then go and do it and upload it right away, so you don't use the same example of that other students use. Now, obviously, we're going to have many students who are going to choose size constancy, or many students who are going to choose, say, color constancy. That's fine. You just can't use the exact same idea that another student used. So, until next time, see you later. Bye.